I didn't really plan for follow-up number 2, but we got new ideas and new information. All right, let's get back to this again. So this is the traditional 10 windings, and then connected together. Fantastic. This was by far the highest loss because of all this length, but we didn't measure capacitance at all. All right, so let's do it with this one as well. Let's also measure 19 picofarads. So let's make the suggestion that Kleinstein suggested, and let's see if this is better when it comes to loss and power and capacity. When it comes to measure capacity, it really tricked me. The previous measurement is absolutely useless. It's bogus. Because of what? This table is anti-static table. So this means it is really funny. Now I place these two toroids on a very high piece of plastic far away from each other, and now I get something very close to 0. Okay, so this is 0.6. Let's just try and move one of them a little bit closer. See how sensitive this is. This is distance of like 2 fingers, right? 1.5. This is crazy. Let's try and make them touch. 6. Are you kidding me? So what happens if I put one of them on top of the other? What do you think? Ta-ta-da-ta! 23, almost 24. Whoa, this is crazy, and this is exactly how I wanted to connect them with wire all the way around here. It's actually going to be a lot worse. So this is not a good idea when it comes to capacity. Look at this. So if you want low capacity, you want the round side and the round side to be like this. And now it's 2 picofarad. So this means if we're trying to put them on top of each other, it's really a bad idea. So now I tried to take some tiny pieces of plastic just to add a little bit of space. This is like 4 or 5 millimeters. So let's just see if we can balance them. Yeah, we could. All right, so that's 8 picofarad. So let's just try and tape all this together in this distance, and then when it's all taped, measure the capacity, and then add the windings and see what is the contribution from the windings and from the 2 toroids. Okay, we're ready to tape them together, but I actually forgot to show what happened with the table. So now they're up here, far away from each other, and we got 0 point almost nothing. Okay, let's try and put them on the table about the same distance. Look what happens. So this is 7, and it's okay. This is the same, about the same distance, right? So that was 7, and I just lift them up. .7. I just realized that one of them fell off. Let's try and put them back on and see if that has anything at all to do with the result. It really doesn't matter if you connect one of them or 2 of them or whatever you do. At least not with this meter, and at least not with the methods that this meter is measuring. I still got like 0.7 or 0.8. It is exactly the same. So that is great. I normally just parallel both ends and then do the capacity measurement, but it seems not to be affecting the results. All right, they're now taped together. This is a super stable construction, and 9 picofarad. Alright, let's try and add the windings. So what shall we do first? Just the 10 windings all the way around, and then connect the windings together and then see how it performs. Let's measure the capacitance. It's nearly 26 picofarads. Let's see if there's any power in this thing, huh? 195 it was. Now I made 10. Please count if you like. 10 individual windings all the way around. Yep, done. I think I made them exactly the same. If they're a little bit more loose or a little bit more tight, I don't know. It's as fair as I can do it under this kind of. Alright, so let's measure. This is very, very close. I would say this is similar. Now, let's test the power. And here we go with the test of the 10 individual wires. And of course, quite a lot of overlap. Remember from the first video, I explained what happens with all this overlap. So, this lamp is annoying. $198, exactly as I thought. A little bit better, and that is, of course, because of the overlapping wires. All this overlap times 10 is quite a lot when you add it all up. All right.